Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so as you see on screen here now, we are already in lecture 3, part 3 of 4, still the topic of 4 Conics, and we're going to look into the subtopic of an ellipse. Okay, so did you recall these all the content that you may just read by yourself. I'm not going to explain all one by one. Okay, since that you have all the you have the lecture notes with you right now. Okay, so this is a picture of an ellipse. It looks like a rugby ball. Okay, an ellipse is defined as a locus at a point of P. Okay, locus point of P here in a plane such that the sum of distance from the P to fixed points is a constant. Okay, and two fixed points are the focus. Okay, so how do we call? There are two types of an ellipse with a horizontal major axis and vertical major axis. As we know that major axis we have a y and also x. So horizontal means that might be we call the ellipse something like this. Okay, supposedly okay, and vertical major axis is something like this. Okay, it's not the proper we call shape of the ellipse, but you can see, you can imagine if this is an ellipse, it's a major of the axis, horizontal axis x, and also major vertical standing up here. Okay. Okay, so then here now, okay, as you see on the screen, so the horizontal major axis means that the major axis, we have the minor and the major axis. The major, this one here, from the let's say, imagine that this is a center. This is center of an ellipse. So the distance of this point here, okay, between A and here, B, and according to this, we can say that it's an A is greater than B. Okay, so look at this one here, A. Okay, A is a major for the x-axis, so x minus h, and then divided by A squared. And class, in some books, they come up with the definition of A is only for x and B is for y. Okay, in some books, A is always we call under the x and B belongs to y, no matter whether A is greater than B or A is less than B. So please be careful, because with different definition, you're going to use A and B to find the point of the focus for C here. Okay, for the center, we call the point of the focus point here, F1 and F2 here. So please be careful if for this lecture notes, A is always, we call the definition of A is always greater than B, meaning A can be under an x, B under y, or A under y here and B under an x. Okay, so it means that here the major of A is under y, so y is the major here. So it's something like just like the rugby ball is standing here, and this one rugby ball lies on the floor. Okay, the focus of F1 and F2, two fixed point, foci, and the vertex. Okay, the vertex point number 1 here and point number 2. Okay, the straight line passing F1 and F2 is called the major axis. The straight line that passing through the F1 and F2 here we call the major axis. This is the horizontal major axis. Okay, and the center of the ellipse H and K, the ellipse symmetrical about the major and minor axis, and the length of major axis is 2a. Okay, never mind. Okay, the length of minor axis B and B. So from here to here, we come up with a 2b. Okay, so equation of ellipse with the center of H and K. Okay, then this is the center. Class, this is okay. From this picture, we notice that this is the horizontal major axis. Okay, so then, well, this is the major, so it might be the F1 and F2 somewhere around here. Okay, never mind. We just follow the flow of these lecture notes. Okay, the center of H and K, so that's the major axis, the minor, and the focus point, the foci of F1 and F2, and that is the vertex, and also the vertex for minor. Okay, C squared equal to A squared minus B squared. So class, again, for our lecture notes, and also take this as our discussion for our syllabus for the whole discussion for this semesters, where A is always greater than B. No matter is A under an X or Y, or B is under X or Y, it's not a matter here, but just take the major value, the biggest one, as an A, and A is always greater than B, because we're gonna fit with this equation here to find the C from this center to the focus point. So we move from H to C unit to the left and C unit to the right. Okay, never mind. Okay, so let's find out now the first one here. Determine the center, the vertices, the foci, length, and also the minor axis of this one here, and sketch the graph. So let's compare with x minus h squared divided by plus with y minus k squared divided by equal to 1. Okay, so look at this one here now. It is 25. 25 is 5 square, right? Okay, and 9 is 3 square. Okay, so what is the center of this ellipse? It is h equal to 0, k equal to 0, so means that the center is 0 and 0. Okay, let's sketch the graph here. So this is the center, 0 and 0. So A equal to 5, B equal to 3, and C square equal to A square. A equal A square, which is 5 squared is 25 minus 3 squared equal to 9. 25 minus 9 equal to 16. So then C equal to 4. Okay. So right now, where A is greater than B, A is greater than B, and A is 5 is under an X. So it means that here it moved 5 units to the left from 0 and 0. We call 5 units to the left and 5 units to the right. Next is B, which is 3 and 3. Okay, from here move 3 units above and 3 units downward here. Okay, now we call C equal to 4, meaning that from 0, 0, move 4 units to the left, which is, this is negative 4, 0, and 4 units to the right, this is 4, 0. Okay, this is negative 4, and this is 4. Okay, class, it's time for us to sketch this picture now. Okay, it might be not very nice because I'm sketching this with a freehand. Okay, something like this. This is V1, V2, V1, and this is V3, and here is V4, this is F1, and this is F2. Okay, so the coordinate of V1, which is negative 5, 0, V2, this is 5 and 0, V3 here, 0 and 3, and V4, 0, negative 3 down here. Okay, then F1 from 0, 0, move 4 units to the left, which is negative 4, 0, and F2, move 4 units to the right, which is 4, 0. There you go. Okay, let's move to the next one then. So this is it. Determine the center, foci, vertices, and major and minor axis of the following here. So let's compare with x minus h square plus y minus k square. So according to this one here, this is 169. I think that is a 13 square, right? Okay, square root of 169 equal to 13, yes. 169 equal to 13 square, and 25 equal to 5 square. So then A equal to 13 and B equal to 5. So A under we call belong to the x under x here, and this is 13 square and this is 5 square. So when the measure under x, so we imagine that this will be something like this, okay, where the major is the x and the minor is y. Okay, so before that, we're going to find out what is the value of c. C equal to a square minus b square. 169 minus 25. Okay, 169 minus 25 is 144. Yes, 144. C square here. So then C equal to 12. So let's list down one by one. The center C equal to this one here, ax minus h. So this x plus, which is x, h equal to negative 4, and y equal to negative 3. The first one. The foci, let's sketch the picture of this first. Okay, negative 4 here, and negative 3. The center, which is negative 4 and negative 3. Okay, so then vertices of major and minor axis, where A equal to 13. A equal to 13 means that from this coordinate of center, we move 13 steps to the left and 13 steps to the right. Negative 4 minus 13 is always here is y is retained as a negative 3. So negative 4 minus 13, negative 17 and negative 3 here. So negative 4 plus 13. Negative 4 plus 13, which I think that end up here at 9. Okay. 9 and negative 3, because same level with the value of y here, negative 3 and negative 3. Okay, then next, from negative 3, the b equal to 5. So negative 3 with both 5 units above, upward, negative 3 plus 5 until 2 here, and then negative 3 minus 5, here supposedly negative 8. This is, from here, the center. From the center, move 5 units upward here. Then this is, okay. What about this? Okay. X equal to negative 4, and 2. And here, which is negative 4 and negative 4, negative 3 minus 5, negative 8. Okay, and then from this center, we move 12 units from negative 4 until negative 4 minus 12 is negative 16 until, and then the y is negative 3. And from negative 4, 12 units to the right. Negative 4 plus 12, here will be 8. And negative 3. So this is the F1, F2, the major, V1, V2. This is V3, the minor, and V4. Okay, class. You may sketch for yourself. Let's say if I move out from this, we call this small point for a while, and let's say we use this one here, y equal to, okay, according to the recall, this is x divided by, okay, first one here, square root of x plus 4 square divided by 169, and then plus with y divided by, okay, here is for y plus, no, y plus 3 in bracket square divided by 25. And let's say this is equation 1. Okay. Let's take a look at this one here now. Okay. As you can see here now, this is the the equation that we substitute into this. We call this space, and we can see the graph clearly. I'll try to make it. No. There you go. Okay. So the center of this we call ellipse, which is negative 4 and negative 3. So negative 4 and negative 3, somewhere around here. Okay. And then the major minor, we call the major axis here, and the focus is over here. Okay, so you may test by yourself. Okay, never mind, I show you one by one. At the coordinate of -4 and -3. There you go, the point here. Then next is F1 at the coordinate of -16 and -3 here, and next one here, A and -3. So this is the focus point F1 and F2. So this is the center. So you may list down here the V1, the vertex of V1 here, major, and also the minor here and here. Okay. Okay, so I show you we call the solution of this just now, and we'll move out from the we call this PowerPoint to see the graph using the desmos.com, and we move to the next question then. Okay, so these are vertical major ellipse, where the major is for the Y. Okay. And again, we compare this with X with X minus H square divided by 4 square plus Y minus K square divided by 5 square equal to 1. So according to this, where A equal to 4, B equal to 5, then C square equal to A square, which is 16. Okay, A belongs to the Y. A is always greater than B, so it is not, it is 25 minus 16. 25 minus 16 equal to 9, then C equal to 3. Okay. So then now here, because this is the, we call a simple example. Okay, so the center of this ellipse H and K, 0 and 0. So the H equal to 0 and K equal to 0. The center at the origin point of 0, 0 here. Okay, then next is BA equal to 5 belongs to the Y. So from here, move 5 units upward, 5, and move 5 units downward, -5. So this is a coordinate of 0 and 5, and this is 0 and -5. And then B equal to 4. So from here, move 4 units to the right, 4 and 4 units to the left. Okay, it looks like the distance from here to 5 and 4 almost equal, right? Okay, we make some adjustment here. Okay, somewhere around here, -4 and 4. Okay, and then so this is the vertex for 4, 0, and here is -4, 0. Okay, sketch the graph of this. Okay, might be not very proper. You may sketch it nicely. The distance of this is 5, and the distance for here, which is 4. So all 5 is greater than 4. And then the C is 3, meaning that here the focus is always on the major. Major now is the whole vertical. So here is 3 and also negative 3. So then F1, which is x equal to 0, y equal to 3, and here is F2, 0 and negative 3. So this is V1 and this is V2, V3 and V4. Okay, so then this one here now. Okay, let's look at the question here. Determine the center, foci, vertices, major and minor axis of the ellipse here. Okay. So for this question, it is x minus 5 squared divided by 9 plus y plus 3 squared divided by 25 equal to 1. Okay, so we compare with x minus h square divided by b square, because a is under y here, belong to y, so this is b, plus y minus k square divided by a square equal to 1. So according to this one here, h k is here is 5 and negative 3. A is square equal to 25, so that a equal to 5. B square equal to 9, so that b equal to 3. Then c is c square equal to 25 minus 9 equal to 16. Then c equal to 4. Okay, so now let's sketch the graph of this. The center is 5 and negative 3. 5 and negative 3. So this is the center now. Okay. Because the major is belong to y, A is greater than b, belong to y here. So then now a equal to 5. A equal to 5. So from negative 3 here, from we call from the center h and k 5 negative 3. This is negative 3. We move 5 units upward. Okay, move 5 units upward. From negative 3 and plus 5, it end up at 2 here. Okay, V1, this is the coordinate of 2. X equal to 5 and y equal to 2. Okay, V1. Negative 3, 5, move 5 units downward. A equal to 5, so 5 units downward. It end up here at supposedly negative 8 here. Okay, so just imagine that this is the coordinate of x equal to 5 and y equal to negative 8. B equal to 3. So from the coordinate of 5 here, move 3 units to the left. So 5 minus 3 equal to 2. Then this is the coordinate of x equal to 2, y equal to negative 3. This is 2 and negative 3. And from here, move 3 units to the right. B equal to 3 here, plus minus 3, plus minus 5. So move 3 units to the left, move 3 units to the right. 5 plus 3 equal to 8. So this 8 here, x equal to 8, and y equal to negative 3. Okay, there you go. And c equal to 4. So from this coordinate, or the center of this point here, negative 3, move 4 units upward. So then c move 4 units here, it end up at 1. So the f1 here equal to x is still 5, and y, the coordinate of y here, from negative 3 plus 4 equal to 1. And from here, move 4 units downward. So negative 3 plus negative 3 minus 4, negative 7. So then f2 equal to still 5, and the coordinate of y here now is negative 7. Okay, so if I use different color here, it will be something like this. Okay, something like that. There you go. Okay, V1, 5 and 2. This is V2, 5 and negative 8. F1, 5, 1. F2, 5, negative 7. And here is 8, negative 3. And this point here, 2 and negative 2. Okay, next. Example 5. Find the equational ellipse with a center at 1, 3, 1 focus at 1, 6, and 1 vertex at 1, 10. And graph the equation. Find the equation of an ellipse. So, we are going to form this equation of x minus h squared divided by a squared plus y minus k squared divided by b squared equal to 1, or x minus h squared divided by b squared plus y minus k squared divided by a squared equal to 1. 1 is for major horizontal axis, or 1 is for vertical major axis. Okay, so let's sketch it so we can see the picture clearly. Center at a point of 1, 3, 1 and 3 here. Okay, 1 focus at 1, 6 focus at 1 and 6. Okay, class. Please do remember that the focus point, foci or focus point, must always add parallel to the line of the major. So, if the one of the focus point here, meaning that it is vertical major axis. Okay, we call the ellipse will be something like this. Okay, vertical major. So, and then one of the f is 1 and 6. So the distance from the center to the focus is 3 units. The distance from center to the one of the focus is 3 units. So another foci or F2 move 3 units downward, which is F2. Okay, here at the point of 1 and 0, and here is 1 and 6. And one of the vertex is 1 and 10. 1 and 10 above here. 6, 7, 8, 9, 10. Somewhere around here, vertex is 1 and 10. So this is the center of 1 and 3. Graph the equation. So before that, we're going to find the equation of an ellipse. H and K, which is 1 and 3. Okay. And the distance from the center to one of the major vertex here, 10 minus 3 equal to 7, where A equal to 7, and then from the center to the focus here, the distance 6 minus 3 equal to 3. C equal to 3. As we know that is a question of A square, C square equal to A square minus B square. Okay, so we are trying to find out what is the value of B here. So then bring this negative B to the left side and C to the side here. So B square equal to A square minus C square, which is A square is 49 minus C square, 3 square equal to 9. 49 minus 9 equal to 40. So then B equal to square root of 40. Okay. Square root of 40, we can simplify this one as a plus minus here. Okay, because we move to the left and right, which is 2 square root of 10. Okay. So now here, x minus h1 square plus y minus 3 square divided by, well, the measure vertically, so then this is 7 square is 49, 7 here, so 7 square is 49, and b is square root of 40, so this is 40 equal to 1. Okay, so you may sketch the picture here. If from 10 minus 3 equal to 7, 10 minus 3 equal to 7, so we move 7 units downward, so 3 minus 7 end up here at negative 4. Okay, from here, and then from 1, 3 move 2 and square root of 10 unit to the left, and here to the right. Okay, so let's move 1 plus 2 square root of 10 and 3 here, one of the we call vertex here, and here is 1 minus 2 square root of 10 and 3. Okay, and this one is 1 and 10, and one of the vertex here is also 1 and negative 4. Then sketch it. Okay. Okay, determine the center and the focus of ellipse by completing a square. Again, we need to form this into a equation of the ellipse. We call from this general equation to the form of x minus h square divided by a square plus y minus k square divided by b square equal to 1. So from the general to the standard form of ellipse, for an ellipse here, we are going to come up with a process of completing the square. Okay. So from here now, okay, never mind. Rewrite everything here on the page. It is 4x squared plus y squared minus 16x minus 10y plus 25 equal to 0. Okay, so now 4x squared minus 16x, put the both next to each other here now, and then y squared minus 10y plus 25 equal to 0. So make sure before we starting record the process of completing the square, make sure that coefficient of x squared here equal to 1. So between these two, we factorize with a 4, x squared minus 4x. 4 times x squared, 4x squared. 4 times negative 4x, negative 16x. Plus y squared minus 10y plus negative 10 over 2 square minus negative 10 over 2 square plus 25 equal to 0. Okay, we may surely come up with the process of completing the square for y because the coefficient of y squared is already 1, but not 4x. Okay, so then 4. Okay, so now x squared minus 4x plus negative 4 over 2 square minus negative 4 over 2 square. And then, okay, never mind, I rewrite this y squared minus 10y plus negative 10 over 2 square minus negative 10 over 2 square plus 25 equal to 0. Okay, now for these three terms here, then we come up with a conclusion that it is 4. This come out with x minus negative 4 divided by 2, x minus 2 square. Negative 4 divided by 2 is negative 2. Negative 2 square equal to 4. Plus with, and this one here, y negative 10 divided by 2 minus 5 square. Then negative 10 divided by 2, negative 5 square is 25 plus 25 equal to 0. So 25 minus 25, okay, 4 times this, 4x minus 2 square, 4 times negative 4, which is negative 16, plus y minus 5 square equal to 0. Then 4x minus 2 square plus y minus 5 square equal to 16. And left and right, we divide everything by 16 here. So then 4 divided by 16, it is x minus 2 square divided by 4 over 16, which is 4, plus y minus 5 square divided by 16 equal to 1. There you go. Okay, now a equal to 16, a square equal to 16, then a equal to plus minus 4, b square equal to 4, then b equal to plus minus 2. Plus minus means that from the center, then we move 2 units to the left, 2 units to the right. And a plus minus 4 here, from the center, it moves 4 units upward and 4 units downward. Okay. Okay, yes, for this one here, a is greater than b here. And then c square equal to a square, 16 minus b square equal to 4, which is 12. Then c equal to square root plus minus square root of 12. Okay, so you you list down everything. Therefore, recall the center, where the center for this one here is 2 and 5. And then V1, because A is greater than B, A belongs to Y here, is a major vertical. So from 2, 5 plus 4, and V2 here, which is 2 and 5 minus 4. And then V3 equal to the minor axis here, the minor vertex, which is 2 minus 4 equal to negative 2 and 5, and V4 equal to 2 plus wait. Okay, 5 plus 4, 5 minus 4, and then this one here, 2. 2 minus 2 equal to 0, and 2 plus 2 equal to 4 and 5. The first focus point, F1, F1 equal to 2 and 5 minus square root of 12, and this one here 2, 5 plus square root of 12. So we all the list here, then try to sketch the picture of the graph for this question by yourself. Okay. So here is an exercise for all of you. Okay, so you may test yourself, and then now I just test the question by yourself. Okay, so this is all the conclusion for the ellipse, standard equation, and here the general equation of an ellipse. Okay, before that, okay class, if I came up with this, we call my conclusion between the standard and general equation. Standard equation and general equation. From standard to general equation, okay, we all need to, well, what we all need is just to recall by expand it and simplify. And from general to standard equation, from this general to standard equation, they come up with the process of completing the square. Okay, so we need to determine every single point that will be labeled here, minor, major axis, and the focus point. Okay. So I'm not going to explain everything here. Please refer to recall your lecture notes again. And I had explained this all from one to another example. All the examples that I recall, I explained you just now in this video. So please refer to my explanation again. Okay, that's all for today. And hopefully that this video helps you to continue with the rest of your tutorial and past year questions. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.